So next, methyl alcohol preparation. Okay, preparation of methyl alcohol having formula CH3OH. So methyl alcohol, generally it is also called as wood spirit or wood alcohol. Okay, common name of methyl alcohol is wood spirit or wood alcohol. And methyl alcohol that is generally prepared from water gas. Water gas in presence of zinc oxide and chromium trioxide at 300 degrees centigrade temperature and 200 to 300 atmosphere pressure. Okay. So, formula of water gas is mixture of carbon monoxide and hydrogen. So, here we get methyl alcohol when water gas is compressed with hydrogen gas. Okay, CO plus H2, that is water gas. Here we are taking 2 moles of water gas. Okay, 2 moles of hydrogen. Okay, CO and 1 mole of hydrogen, that is water gas. But here we are additionally adding the hydrogen here. Okay, so this water gas mixer. So in presence of zinc oxide and chromium trioxide at 300 degrees centigrade temperature and 200 to 300 atmosphere pressure. Okay, it converts into methyl alcohol. So this is important reaction, preparation of methyl alcohol from water gas in presence of mixture of zinc oxide and chromium trioxide and at 300 degrees centigrade temperature and 200 to 300 atmosphere pressure. Okay, then coming to physical and chemical properties of alcohols. Physical and chemical properties. Alcohols. First coming to physical properties. Alcohols, generally they are in liquid state. For example, ethyl alcohol. Ethyl alcohol is a colorless liquid and it burns with a blue flame. Okay. Then alcohol generally they get soluble in water. Okay. So ethyl alcohol gets soluble in water because it forms intermolecular hydrogen bonds in water. Okay. So due to the formation of intermolecular hydrogen bond, alcohols get soluble in water. Okay. So alcohols are soluble in water due to the formation of intermolecular hydrogen bonds. Intermolecular hydrogen bonds. Okay. So for example, if alcohols are in water, they forms ROH. This is alcohol. Okay. So they forms intermolecular hydrogen bond. So dotted line indicates intermolecular hydrogen bonds. Okay. So due to the formation of intermolecular hydrogen bonds, they are generally get soluble in water. Okay. Then coming to boiling points. So this is solubility. Solubility, that is in polar solvents like water. So alcohols are more readily get soluble in water because they forms intermolecular hydrogen bonds. Okay. Then boiling points of alcohols are very higher than ethers and alkyl halides. Why? Because intermolecular hydrogen bonds are formed by alcohols. So due to this reason only, alcohol shows very high boiling point. due to intermolecular hydrogen bonds. Okay, so boiling points of alcohols are more than boiling points of alkyl halides, ethers. Okay, so alcohol shows very high boiling points due to the presence of intermolecular hydrogen bonds. Next, so in alcohols, boiling point is very high. In case of some isomeric alcohols, as branches increases, in isomers as branches increases, boiling point gradually decreases. Okay, so in isomeric alcohols, straight chain alcohol shows higher boiling points than the branched chain alcohols. Why? Because surface area of alcohols gradually decreases as branching increases. Okay, as branching increases, automatically boiling points gets decreases. Okay, so in isomeric alcohols, boiling point decreases as branching increases. This is due to decrease in surface area. Okay, so as branching increases, boiling points gets decreases. That is because of decrease in surface area. Okay, then coming to chemical properties. Chemical properties of alcohols. So coming to chemical properties, here we can divide total chemical properties in two categories. Okay, so you know about general formula of alcohol, R OH. So here R is alkyl group, CS3 C2H5. Okay, so R indicates here carbon. Okay, so coming to chemical properties, two types of chemical properties are there. Chemical reactions involving cleavage of OH bond. Okay, and chemical reactions involving cleavage of CO bond. Okay, so we observe cleavage of OH bond, two categories of chemical properties. Okay, so breakage of OH bond and breakage of CO bond. Okay, so two types of chemical reactions. So first coming to chemical reactions involving OH bond. Okay, cleavage of OH bond. Okay, so let us see some chemical reactions which involve OH bond. Okay, for example, reaction with the sodium metal. Okay, so ethyl alcohol, for example, ethyl alcohol is there. It reacts with the sodium metal. Okay, here we get sodium ethoxide with the liberation of hydrogen. Okay, so we get C2H5ONa. Okay, why? Because bond between oxygen and hydrogen gets cleaved. Okay, and liberates hydrogen. Okay, we get sodium ethoxide. So in this chemical reaction, cleavage of oxygen and hydrogen takes place. Okay, then coming to esterification reaction. This is very important reaction. So this is with the sodium metal. And esterification reaction. This is important. Esterification reaction. So in esterification reaction, this is also called as Fischer esterification reaction. Ethyl alcohol reacts with acetic acid in presence of acid which acts like a catalyst. Okay, we get ester. Okay, so acetic acid with the ethyl alcohol in presence of acid catalyst. Okay, we get ethyl acetate along with water. So this is esterification reaction. Okay, and this is also called as Fischer esterification reaction. Fischer esterification.